Welcome back to Solving Problems Together. Today we're going to dive straight into a problem that involves geometry and unknown angles. We've been given this diagram, and the only extra information that we have is that the marked angles are congruent, meaning they're the same size. So in the bottom left corner, the two dashed angles are the same size, and in the bottom right corner, the two dotted angles are the same size. We need to try and find the size of angle X. So as always when it comes to problem solving, let's just take a moment to think about what maths might actually be useful in approaching this problem. Firstly, we're working with angles, so there's a potential for angle facts to come into play. So angles on a straight line, vertically opposite angles, angles around the point, any of these can be used. And angle facts immediately extend into angles within polygons. So the angles within a triangle, a quadrilateral, a pentagon, a hexagon, etc. And since we have an unknown and we're actually looking for that unknown value, we're going to be forming and hopefully solving equations. These are my initial thoughts, so let's get started and see what we can generate to help us solve this problem. Firstly, I'm going to relabel some of these angles for easy reference. So the dashed angles become A's and the dotted angles become B's. Now, looking at the whole shape that I have here, if I just trace the outline, the perimeter of the shape, I have a quadrilateral. And I do know that the angles in the quadrilateral should add up to 360 degrees. In fact, for any polygon, we can find the sum of the interior angles using this formula. So the sum of the angles within a polygon will always be a multiple of 180. And to find the factor that you'll use, it's going to be the number of sides minus 2 multiplied by 180. A triangle has 3 sides, subtract 2, gives you 1 multiplied by 180. We know a triangle has 180 degrees. A quadrilateral has 4 sides, subtract 2, gives you 2, times 180, 360 degrees. I know that each of the angles in a corner, each of the angles in a vertex, when added together should equal 360. So let's form an equation. 2a, starting in the bottom left, plus 2b, moving anti-clockwise, plus x, plus 120, all together equal 360. Okay, I can tidy that up, just simplify, get the constant values onto the right hand side, and here we get 2a plus 2b plus x equals 240. I've got an equation with 3 unknowns. To solve for 3 unknowns, we typically would need 3 equations. Let's see if I can find any more equations. I'm going to move from thinking about a quadrilateral to thinking about a pentagon. And here is the 5-sided pentagon I'm going to focus on. Once again, using the sum of angles in a polygon formula, 5 minus 2 gets us 3. 3 times 180 is 540. These interior angles should add up to 540. Before I form an expression, there is one angle that's missing, and it's this reflex angle right here. We know that the angles around a point sum to 360, so this must be 250 degrees. Okay, so now I've got the 5 interior angles of the pentagon, and they will sum to 540. So a plus b plus x, and the 2 numbered angles together give us 370. Tidying this up a bit, a plus b plus x equals 170. As I said before, we would typically need 3 equations to fully solve for 3 unknowns. I only have 2 equations at the moment, but the questions only actually ask me to solve for one of these unknown values. Looking at the equations, I can take one step to make my life easier. If I double the last equation I've written, multiplying each of the terms by 2, I get a very nice situation. Here I notice that both equations have 2a plus 2b, meaning I can eliminate that whole expression. Let me show you how. So, 2a plus 2b plus 2x, 2a plus 2b plus x. If I subtract the blue equation from the red equation, the a's are going to cancel out, the b's are going to cancel out. I'll be left with x equals 100. And that's actually what we were looking for in the first place. So, although I thought I might need 3 equations, I managed to do it with 2. I haven't got a full solution for the simultaneous, but I've solved the problem that we were given in the first place. I'm not sure we have enough information at the moment to solve for A or B, but if you can take this problem any further to make it more challenging, if you have any other techniques that you used to solve the problem, or you had some alternate initial thoughts, do let us know down in the comments below. Thanks for joining us, and do come back soon so we can solve another problem together.